Machine learning has stolen the spotlight. It has become the number one search trend during the year of 2019 and continues to grow unimaginably. More and more of us are becoming aware of what machine learning can help us achieve, but really do not know how to make use of it. So, let's take it a step further and understand machine learning is really about. Dive deep into the realm of unsupervised learning and come about with answers to the questions that we have. Hello, everyone. This is Akash from the Edureka team, and I welcome all of you to this interesting session on unsupervised learning. Let's take a look at the topics that we shall cover in today's session. We shall briefly discuss what machine learning is, go in depth with unsupervised learning, its importance, and the types comprising of clustering and association algorithms, its applications, the differences between supervised and unsupervised learning, and end the session going through the disadvantages of unsupervised learning. Now, before we get started, subscribe to the Edureka YouTube channel and hit the bell icon to never miss an update from us on the trending technologies. Also, if you're looking for an online training certification on machine learning, check out the link in the description box below. Let's jump right into the first topic for today. What is machine learning? Machine learning, in the simplest of terms, is teaching your machine about something. You collect and clean the data. You create algorithms, you teach the algorithm essential patterns from the data, and then expect the algorithm to give you a helpful answer, right? If the algorithm lives up to your expectations, you have successfully taught your algorithm. If not, you just scrap everything and start from the scratch. That's just how it works. And if you're learning for a formal definition, machine learning is the process of creating models that can perform a certain task without the need of a human explicitly programming it to do something. So machine learning has been broadly classified into three types. It is supervised learning, unsupervised learning, and reinforcement learning. So let's talk a bit about these three. Under supervised learning, you supervise the learning process, meaning the data that you have collected here is labeled. So you know what input needs to be mapped to what output. So this helps you correct your algorithm if it is making a mistake in giving you the answer. Unsupervised learning works the complete opposite. The data collected here has no labels and you are unsure about the outputs. So you model your algorithm such that it can understand patterns from the data and output the required answer. You do not interfere when the algorithm is learning. Reinforcement learning, on the other hand, is completely different from the rest. There is no data in this kind of learning, nor do you teach the algorithm anything. You just model the algorithm such that it interacts with the environment. And if the algorithm does a good job, you reward it. Else, you punish the algorithm. With continuous interactions and learning, it goes from being bad to being the best that it can be to the problem that is assigned to it. So, with a basic idea of what machine learning is, let's move over to the main topic for discussion today, unsupervised learning. So, what is unsupervised learning? As discussed earlier, it can be thought of as self-learning where the algorithm can find previously unknown patterns in the data sets that do not have any sort of labels. Let me give you a real-life example that you may have encountered and you can relate to understand what exactly is this kind of learning. Suppose you have never watched a cricket match in your entire life and you have been invited over by your friends to hang out at their house for a match between India and Australia. You have no idea about what cricket is, but just for your friends, you say yes and head over with them. The match starts and you just sit there blank. Your friends are enjoying the way Dhoni plays and want to join in the fun, right? So here is where you start learning about the game. You analyze the screen and come up with certain conclusions that can help you understand the game better. So there are basically two teams with the jersey of colors blue and yellow. Since Dhoni belongs to India and you have the score of India on the screen, you conclude that India has the jersey of color blue, which makes Australia have yellow jerseys. There are different types of players on the fields. Two which belong to India have bats in their hands, meaning that they are batting. There is somebody who runs up and bowls a ball, making him a bowler. There are around 9 players around the field who are trying to stop the ball from reaching the boundary of the stadium. There is someone behind the wickets called as the wicket keeper, and there are two umpires to manage the match. If the ball hits the wickets or if the ball is caught by the fielders, the batsman is out and he has to go back. Dhoni has the number 7 and his name on the back of his jersey. And if he scores a 4 or a 6, you need to cheer. So you make all these observations one by one, and now you know when to cheer or boo when the wickets fall. From knowing nothing to knowing the basics of cricket, you can now enjoy the match with your friends, right? So what happened here? You had every material that you needed to learn about the basics of cricket. The TV, when and who your friends are cheering for. This made you learn about cricket by yourself without somebody guiding you about it. This is the principle that unsupervised learning follows. So, having understood what unsupervised learning is, let's move ahead and understand what makes it so important in the field of machine learning. Moving ahead, unsupervised learning also helps us obtain a lot of information about the way it works. So, unsupervised learning algorithms work on data sets that are unlabeled, which can help you find patterns which may not be previously known. So, how do these patterns help us? These patterns help us in categorizing the elements or finding an association between them. They can also help us detect anomalies and defects in the data sets that we have collected, which can be taken care of by us. Lastly, and most importantly, data which is collected by us is usually unlabeled, which makes the work easier for us when we have to use these algorithms. So it is essential that you understand the importance of unsupervised learning, because this will help you decide whether these algorithms are the ones which you need to work with so that you can solve your problems. So with that, let us move ahead with the types of unsupervised learning. Now, unsupervised learning is also broken down, and more precisely, it is broken down into two parts, which are association and clustering. So, what do these two types do? Clustering is a type of unsupervised learning where you find patterns in the data that you are working on. It may be the shape, the size, the color, which can be used to group data items or create clusters basically. So some of the most popular known algorithms are k-means clustering, KNN clustering, hierarchical clustering, and many more. So let me just show you an example of how clustering works. Suppose we have a basket of fruits over here, and we just lay up all the fruits on the table, and we have these fruits on the table over here, and we make our algorithm work. So we are just checking for the color, the size, the shape, and all of that, and we come to a conclusion that there are three fruits over here. We have strawberries, we have oranges, and we have apples. So this is just one way of how unsupervised learning works. This is called as the clustering mechanism of unsupervised learning. Whereas we have association. So association, on the other hand, is the kind of unsupervised learning where you can find the dependencies of one data item to another data item and map them such that they can help you profit better. So we have algorithms such as the a priori and FP growth, which are very popular for association. So for association, we have an example of a supermarket analysis. So basically, a buyer is trying to buy bread. So if he buys bread, it is most likely that he's even looking for butter or he's looking for jam or something like that, right? So if he buys butter or jam, he's also looking for milk. So basically, what happens over here is you are mapping the dependency that if you buy butter, you have to buy bread, or if you have to buy bread, you buy milk, or something like that. So it is made sure that once you have bread on the rack in the supermarket, next to it should be butter and next to it should be milk. So this is how basically association works in unsupervised learning. We have the different types that I just discussed right now, which was k-means, KNN, hierarchical, a priori algorithm, and so on. So I have small examples of these algorithms. So let me just move over to PyCharm and teach you guys more about these algorithms practically. Yes, so the first algorithm that we will be discussing about is k-means, right? So I have imported all of the required libraries. I have the plotter library, which is the matplotlib. I have the sklearn.cluster from which I have imported the k-means algorithm. And I have the sklearn.datasets.sample generator, which I import make blobs. Basically, what happens over here is I am making my own dataset by randomly generating data points, right? So I have this particular library here, which I am using to generate random inputs so that I can work with my k-means clustering. So I have X and Y and I am creating the blobs over here. So X will hold the inputs and Y will hold the outputs. And then I am saying that plot everything which are belonging to the column 0 and plot everything which are belonging to the column 1 and show the output. So let me just explain the algorithm right now so that I can show you how everything works later. So now what's happening is I have a list where I'm going to add all the outputs of the value that I'm going to get from the k-means. So I have for I in the range of 1 to 11, which means I am running it 10 times, and I am just having k-means clustering of I, and I am going to fit the algorithms, and I'm just going to check if it is working or not. So what's happening here is I am finding for the elbow method. Now, what is the elbow method is basically run the algorithm for many number of times. Wherever you have the drastic drop in your output, that is where you have to create the k-means clustering. So that's what I do, and I have already run the algorithm, so I know that the cluster that I obtain over here is 3. So I just predicted and I just obtain the output. So let me show you exactly how this works. So let me run the program. So I'm going to get graphs on the output. So yeah, as you can see, these are the different data points that were created using the make blobs function. So all these are the data points accordingly. So let me close this. So my next function works. So as you can see, for 1, it was showing the most significant amount of distance. Then we have 2, then we have 3 over here. So as you can see, there was a huge drastic drop when it came to 3. So this is where my k-means clustering has to be made. So as you can see with the elbow method over here, I am able to find out or identify that the most optimal number of clusters that I have to make for my data set is 3. So this is basically the centroid, and this becomes one cluster over here. This is the second cluster, and this is the third cluster. So I hope that's clear of how k-means algorithm works. Let me just get out of here and run the other algorithm. So that was k-means. Let me go ahead and run knn. Yes. So as you can see over here, I have imported the iris dataset, and then I am having the k-means, k-neighbors classify over here. I have the train test split data, all of it. So I have iris is equal to load iris, and I am just giving the data and the target accordingly. And then I am splitting the data set over here. So it is 33% of testing and 67% of training data. And I am just going to fit the algorithm accordingly, and I'm just going to show the algorithm over here. So I hope you understand how this is. Let me run the program. Yes. So as you can see over here, I have the most accuracy when it came to around 8 up to 12. And then I had the most accuracy with 21. So as you can see, this is the plotting of the accuracy, and it is being clustered the same way. So I hope that's clear to you guys. So that was knn algorithm for you guys. Let me move ahead and show you hierarchical. So let me just show you hierarchical clustering. So I have imported all the required libraries, and this is my input over here, which I have given by myself. So what I'm going to do over here is for all the data points, I'm going to give the labels to them, right? So how are the labels going to be? So labels range from 1 to 10, meaning that it will be starting from 1 up to 10 and excluding 11. So I'm just going to scatter my data points. And then for the label X and Y in the zip function of labels and my inputs, I'm just going to annotate, meaning that for one data point, I'm going to give 1, 2, 3, and so on accordingly. So I'll show you how the output looks, but let me just explain the full program for now. So over here, as you can see that I'm just going to find out the different types of hierarchies. So this function, the dendrogram, is going to find the hierarchy for me. And then the algorithmic clustering is just going to tell me how the clustering is going to happen. So let me run the program for you. Yes. So as you can see, I have all the data points that is scattered, and I have given them the labels 1, 2, 3, and so on accordingly, right? So let me close this up. As you can see over here, this is how the hierarchy happens. So it will directly take 1 and 2 and make them a cluster. Then 1, 2, and 3 will be made a cluster. Then 1, 2, 3 with 0 is made a cluster. Then 1, 2, 3, 0, and 4 is made a cluster. The same way it works over here also, right? And then the whole thing is made as a cluster. So this is green and this is red. Let me show you how the clustering is after the, output working. So as you can see, this is one cluster and this is the other cluster. So that is how the hierarchical clustering works. Let me move out of here and let me show you a priori algorithm. Now, a priori algorithm is working a little different over here because we have a data set over here. So let me just show you how the data set looks. So basically what happens over here is I am showing you the different types of ways that users have bought the data. So if it was chutney, it was just chutney. If it was turkey, avocado was also bought. Then if it was low fat yogurt, then it was just low fat yogurt. Then if we had whole wheat pasta, even French fries was bought. So that's how this whole data set works. Okay. So let me just show you how the program is. Yes. So I have imported the pandas because obviously I'm working with the CSV file. And I also have the a priori algorithm, which I have imported from the a priori. Now I'm just going to read the data and I'm not having any headers over here because this is obviously unlabeled data, right? So I have to make sure that the headers are not there over here. So yeah, another thing that I forgot over here to mention is why is it between the range of 0 to 7500 is because the data set that we are working on has 7500 inputs. It has 7500 rows. So that is the reason we are working with 7500 range over here. Okay. So I hope you're clear with that. Now, what I'm going to do is I'm just going to append all the records. So let me tell you how this particular statement works. Okay. So for I in the range is for all the rows accordingly, right? So I'm just going to append all the rows and their particular columns also. And the columns are being appended using the J function. And J will only work for J in the range of 0 to 20 because the maximum columns that we have were around 20, right? So then we are making rules over here. So a priori records, all of those confidence, minimum support, all of that I have given over here. And then I am just making it a list. So all the rules that I have obtained, I am just making it a list and saving it into association rules. So let me just show you how everything works. And what I have done over here is basically I have formatted how everything has to look. So let me just tell you how support, confidence, and lift works basically. So what is support is basically the individual popularity. So for example, if you remember, I had chutney. So chutney had its individual popularity. So it would be definitely taken. So that is how it is. So it is calculated using the item A with the total transactions in the whole data set. Okay. Then I have something called as confidence, meaning that it is item A which will induce more profit in item B. Like if you buy bread, it will obviously make the profit of butter also more, right? So how is that calculated? It is item of A plus B divided by the item A. And then we have what is lift. So lift is basically how much of induction of profit is item A giving to item B, right? So let me run the program. And so I will get all the rules over here. So let me show you how the rules will look. So all the rules over here which have succeeded or surpassed more than the minimum confidence and support levels that I had given in the algorithm, all of those will be printed over here. So let's just, yes. So as you can see, if there is chicken, light cream will also be taken, and how much is the support, confidence accordingly. So if I have mushroom cream sauce, then escalapo will also be taken, pasta, escalapo, and yeah, according, all the other values are shown over here. So I hope that was clear to you guys. Let me just close this up. So I hope that gives you a clear idea of how the working of these algorithms is and how they are so simple and easy to implement because of the huge library and the community support we have. So let's move over to the applications of unsupervised learning. So unsupervised learning has found its way into a lot of applications all around. They help us in understanding patterns which can be used to cluster the data points based on the various features, in understanding various defects in the data set which would not be able to detect initially. They help in mapping the various data items to all the other dependencies like we just saw, then cleansing the data set by removing features which are not really required for the machine to learn from. So they are used in renowned applications such as Airbnb, where if the user is querying their requirements, Airbnb learns these patterns and recommends stays and experiences which fall under the same group or cluster. Basically, it is using the clustering method over here. Then we have Amazon. So Amazon learns from the customer's purchase and recommends them the products which are, frequently bought together and so on. And then it is also used in finding the credit card fraud detection. So various patterns of the users are studied and how they use their credit cards and all that. So if the card is out of the behavior of what the user generally does, an alarm is generated. So it can help you find out if the credit card is being used by a fraud or not. So with that, let's understand how supervised learning is different from unsupervised learning. We have a set of parameters on which we shall differentiate the two. We have data sets, we have the method of learning, we have complexity, we have accuracy. So let's see how these fare against each other. So in supervised learning, the data set is always labeled, whereas the data set is unlabeled in unsupervised learning. The method of learning in supervised learning is guided, meaning that you are guiding the algorithm to learn. Whereas in unsupervised learning, algorithm learns by itself using the dataset. And so for the complexity, unsupervised learning is much more complex than what we have for supervised learning. And supervised learning are more accurate rather than unsupervised learning, which may be lesser accurate. Now, understanding the differences between each other, let's move over to the last topic, which are the disadvantages of unsupervised learning. It may seem that unsupervised learning is too perfect, but no, it is not. It has also its share of disadvantages. There is no way of obtaining the way or the method the data is sorted, as the data set is unlabeled. There may be lesser accuracy because of the input data which is not known and labeled by the humans, making the machine do it. The information obtained by these algorithms may not always correspond to the output that we wanted or what we required. The user has to understand and map the output obtained for the corresponding labels. So barring these problems, unsupervised learning does help you out in a lot of ways and is probably one of the best kinds of machine learning, primarily because of the way they output their data. You do not have to clean anything, they clean the data for you, and you can make sense of this for data analysis and much more. So with that, we have come to the end for today's session. I hope it was fun and interesting to learn, and if there are any doubts, please leave a comment for us in the comment section below, and we will try to get back to you as soon as possible. So till next time, take care and happy learning.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!